Alright guys, today we're going to take a look at this new method of proving, which is proof by contradiction. We want to prove the following statement. Prove that square root of 2 is irrational. So how will we do this? We'll do this by assuming square root of 2 is rational. Right? So the reason of doing this is because a number is, if you think of any number, is either a rational number or is a irrational number. So if we can prove this statement is false, then it must be an irrational number, right? So how we do this? So we already know that in my last video that a rational number can be written in the form of an integer over another integer. So we can write this in the form of an integer over another integer because we already assume that is rational, right? So let's write it as, in the form of p over q, where p, I write in p, q are integers, q is not equal to 0. So one of the really main thing I want to say about here that's really important, that is actually so important. Way p and q doesn't have common factors. This is really important. I need to put this in mind. I'm actually gonna square it like this so you can remember it more clearly. So we right now assume that square root of 2 is rational. We written in the form of an integer over another integer. We can further simplify this equation here. So how can we get rid of the square root? How can we get rid of the square root? We can get rid of the square root by squaring the top and the bottom, right? So which will get us 2 is equal to p squared times q squared. And if we further simplify this, we can write this in the form of 2 times q squared is equal to p squared, right? That's just algebra. So if you look at the structure, you'll find out that this is an even number, because the q here is an integer, and if you times an integer by 2, you'll for sure get an even number. So any integer you times it by 2, you will get an even number. So we know that 2q squared is an even number, and we have a equal sign in the middle. So which means that p squared must also be even. So p squared is even as well. And one of the properties that if p squared is even, then p must also be even. I'm not going to do the proof here, but you can maybe do some examples. Maybe let's say 4, right? 4 is an even number, right? 4 squared is 16. 16 is an even number, right? So if p squared is even, then p must also be even. We know that, right? So let's actually write this. If p is even, we can write p in the form of 2 times m, where m is another some kind of integer, right? So we know if a number is even, so any number that is even, you can always write it in the form of a 2 times some random integer. So 2 times m will be our p right now, right? Because 2 times m is even and p is even, so they're equivalents, right? So actually, let's further go down with our equation here. So 2q squared equals to p squared. We know that p squared is we know that p is 2m, so we can change this to 2q squared is 2m squared. I just replace p with 2m because I already said that 2m is our p and they're both even, so they're equivalents, right? So what is 2m squared? You can further go down with this, which is 4m squared. So how you further simplify this? Well, you divide both sides by 2. So divide by 2, 2 cancels out, 1 and 2. So this leaves you to q squared is equal to 2m squared. Well, if you look at this is interesting because 2m squared is even. Same as the reasoning that I said that 2q squared is even, right? Because because we know that m is some kind of integer, and 2 times n must be an even number. So if 2m squared is an even number, well, now q squared must be even as well, right? If q squared is even, q must also be even. So if we look at this property, q is a even number, and we write it right here. P is a even number, so we connect them. Remember that we wrote at first that square root of 2 can be written in the form of P over Q. And one of the most important property that I wrote is that P and Q doesn't have any common factors. So you can't factor out between. There's no common between them. But right now, we already know that P is even. Q is even. So what does that mean? That means they must have a common factor of 2, because any even number can be written in the form of 2 times some kind of integer. If the top and the bottom are both even, they can both be written in the form of 2 times an integer, which is not allowed, because at first I already assumed that P and Q doesn't have any common factor, right? So, but in this statement, I just proved that square root of 2 can be, P and Q can be even. But right now, the problem, if they're even, they have a common factor of 2, which defies what I assume in the first place. So therefore, square root of 2 is not rational, because I assume that square root of 2 is rational, and I just proved that it's false. So now square root of 2 must be irrational. So therefore, square root of 2 must be irrational. So you can see how interesting this is. I assume that square root of 2 is rational, and I proved that it cannot be rational, so therefore it must be irrational, which is this way of proving, which is so-called proof by contradictions, by assuming the statement to be the opposite, to contradict. So that'll be our video today on why square root of 2 is a irrational number, and I hope you learned something.